Hi there, and welcome to another Pencast for the course Reasoning and Logic. This one is about an old exam question, which asks us to prove a certain property of right-angled triangles. Now, most of the proofs that we've seen so far, including in other Pencasts, talk about numbers only. This one, well, it seems to be about triangles, about three sides, A, B, and C, although the A seems to have fallen off of my video for some reason. And it asks us to prove a certain property of these triangles, namely that A plus B is always larger than C. And it asks us to do this using a proof by contradiction. Now don't let this scare you. This is also a proof about numbers. It just so happens that the numbers also mean something more. They also happen to represent sides of a triangle. So proof by contradiction. Where should we start? Well, just like in any proof by contradiction, we should assume the opposite of what we want to prove. In this case, we should assume that there is a triangle that doesn't have this property. So assume there's a triangle with A plus B is smaller than or equal to C. And then it's time to do some math. First, we square both sides, so we get A plus B squared must be smaller than or equal to C squared. Since all of them are larger than 0, remember, they're sides of a triangle. This must be true. Then we work out the squares on the left side, and on the right side we apply Pythagoras. Remember that A squared plus B squared equals C squared, according to Pythagoras. So remove some stuff from both sides, and we get 2AB is smaller than or equal to 0. But this is not possible, because remember, A and B are sides of a triangle. They can't be negative. So 2 times something positive, or in fact something strictly larger than 0, because they're sides of a triangle, that must be larger than 0. So it cannot be smaller than or equal to 0. So we found a contradiction. In other words, there is no such triangle such that A plus B is smaller than or equal to C. Therefore, all of them must have the property that A plus B is larger than C. QED. So, a 2-minute proof that is about triangles, but, well, when we get down to it, most of the math we do is just about numbers. Numbers with certain properties. The properties that they're larger than 0, for instance. So there you have it. A proof about numbers that is actually a proof about triangles. And with that, we've come to the end of this Pencast. See you around for the next one.